So the big picture for this lesson is the cube root function. And here I did the parent function f of x equals the cube root of x, and I made an input-output table using perfect cubes for x so they'd be nice integers to graph. So I'm going to go ahead and plot the points. First of all, -8, and then -2, -1, -1, 0, 0, 1, 1, and then 8, and then 2. Then the graph should look something like this. Okay, so starting from 0, 0, the graph increases at a decreasing rate, and then moving to the left into the negative values for x, the graph is decreasing at a decreasing rate. So what are the domain and range? The domain is simply x is an element of the set of real numbers because it continues forever left to right. The range, y is an element of the set of real numbers. Same reason. It's very gradual here, but the graph eventually increases forever. And moving to the left, the graph eventually decreases forever. So the general form of the function is this. F of x equals a times the cube root of bx minus h, then plus k, where a is the vertical stretch, shrink, or reflection, and b is the horizontal stretch, shrink, or reflection, and the h is left to right translation, and the k is up or down. So you're going to be evaluating the cube root function. You're going to be transforming the cube root function. I'll do one transformation, starting with f of x equals the cube root of x plus 2, then minus 1. And let's say g of x equals 2 f of x minus 1. So what happens here is the 2 is going to be the a, or the vertical stretch, and then the minus 1, that is going to be an additional translation up or down. So here's what it's going to be. G of x is going to be equal to times the cube root of x plus 2, and then it's going to be minus 1 again, so minus 2. And that's how you do that transformation. So that's the big picture for this lesson.